Hello everyone. What we're going to do in this video is we're going to start breaking down all of these kind of key features that we're looking for when we're trying to graph a rational function. Specifically in this video, I want to take a look at how to find the x and y intercepts of a rational function. This is where we're going to focus our attention for this video. Okay, so what I'm going to do is I'm just going to go ahead and draw what a typical rational function might look like. So when graphing a rational function, let's see, can I get a better marker? My daughter came in here and messed around with all my markers, so I can't tell which ones are good and bad anymore. I try to turn them upside down to kind of use as much as I can. Sometimes they don't last as long. Okay, so a typical rational function, it can have multiple vertical asymptotes. Okay, so it could, I don't know, it might have one here, it might have one here. It turns out that we can actually only have one horizontal asymptote, but we could have multiple vertical ones. Okay, so maybe the graph, maybe the rational function, I don't know, it could look, maybe, I don't know, it could look something like this, for example. This is an example of some rational function. They typically look something like this. Okay, so what we want to hunt for is we want to hunt for the y-intercepts. So this would be the y-intercept. And we want to focus specifically about y-intercepts. What's special about y-intercepts? How do we find y-intercepts? This is when x equals 0. This is when x equals 0. So I want to know what the output of the function is when x is equal to 0, and that'll tell us our y-intercept. If I want to know about our x-intercepts, okay, let's say that this function has a name, some rational function, we'll call it r of x. So this is when x equals 0. So how are we going to find the y-intercept? Okay, we're going to plug in. We're going to plug in 0 into our function. Okay, how are we going to find our x-intercepts? So these here are our x-intercepts. How are we going to find those? Well, that's when the output of the function is 0. That's when, I guess you could say, when y is 0, or if I'm using function notation, this is when r of x equals 0. Okay, so here I'm saying that r of x and y are the same. Okay, so that's when y is 0 when r of x is 0. So I'm going to want to solve this equation. So how am I going to find x-intercepts? Okay, we are going to solve. We're going to solve r of x equal to 0. So that's in generally how we're going to find y-intercepts and how we're going to find x-intercepts. Let's go ahead and do some examples. Okay. Okay, so finding x and y intercepts for a rational function. Okay, so what's going to help us here is remember that a rational function, r of x, what is the definition of a rational function? It's a polynomial divided by another polynomial. So here, p and q are polynomials. Okay, so we want to find the x and y intercepts. Okay, so our first example is, let's do r of x being equal to, how about 4x plus 1 all over x squared minus 4x plus 4. So here's our rational function. Let's first go ahead and find our y-intercept. So remember, a y-intercept is when x equals 0. So I'm simply just going to plug in 0 into this function and figure out what the output is. So here we'll have that r of 0 is going to be equal to 4 times 0 plus 1 all over 0 squared minus 4 times 0 plus 4. So what are we going to get here? Well, it looks like in the numerator I'll just be left with 1, and in the denominator I'm just going to be left with 4. So we have our y-intercept. Our y-intercept here is 0 and 1/4. This is our y-intercept. Beautiful. Our y-intercept. Let's go ahead and now find the x-intercept. Okay, so our next job is let's go ahead and find our x-intercept. Okay. So when we're trying to find our x-intercept, this is when y equals 0. This is when the output of 0 is, or just a y and r of x are the same thing. This is when r of x is equal to 0. I want to know what values of x give me an output of 0. Okay, so how are we going to do this? I'm going to leave ourselves a little bit of room here. Okay, kind of go up here a little bit. So we're trying to find our x-intercept. So to find our x-intercept, we want to solve r of x being equal to 0. Okay, so let's go ahead and set this up. So I need to solve the equation 0 equals 4x plus 1 all over x squared minus 4x plus 4. Okay. So how are we going to solve this equation? How are we going to solve this equation? Okay, well, let's notice something. Let's notice that this equation involves fractions. Gross. Gosh, I hate when there are fractions in equations. And I've been doing math for a long time, and really one of the best things you can do in math is try to avoid fractions. So what am I going to do with this? I'm going to clear the fractions. Anytime you see an equation with fractions in it, you should clear them. How am I going to clear them? I'm going to multiply both sides by the denominator. I'm going to multiply both sides by x squared minus 4x plus 4. And x squared minus 4x plus 4. I'm going to multiply both sides. Okay, so on the left-hand side, 0 times anything is 0. So I get 0 is going to be equal to, well, what happens here is these cancel out. So I'm just left with 4x plus 1. 4x plus 1. And now what we can do here is we can go ahead and solve this. So let's go ahead and subtract 1 from both sides. So I'm going to get that negative 1 is equal to 4x. How about I divide both sides by 4? Dividing both sides by 4 looks like what we get here is that x is equal to negative 1/4. So it looks like we have one x-intercept, and it's at negative 1/4. Okay. So let's write that down. So our x-intercept, well, what we just discovered is that if we plug in negative 1/4, I get an output of 0. So here is our x-intercept. Okay, let's make an observation. Just to note here that you don't have to do this every time. Let's think here for a second. How did I actually figure out where the x-intercept was? Notice that after I cleared the fractions, it just came down to us trying to figure out where the numerator was 0. Where the numerator is 0, that's when a fraction is 0. That's when a fraction is 0, is when the numerator is 0. So in this case here, I mean, think about it. You know, this is, I guess it's just something to talk about that students kind of get confused about. But for example, if I have 0 fourths versus like 4 over 0, for example, or let's say I have something like I have 8 over 4. Let's just examine these fractions here for a second. What does this say? What does fractions mean? This is saying that I have 8 items, and I'm splitting them between 4 people. So how many items does each person get? 2. Okay. This is saying that I have 0 items, and I'm dispersing them amongst 4 people. So if I have no items to give to 4 people, how many items does each person get? They get nothing. Over here, this is saying that I have 4 items to split amongst no people. So how many items does each person get? But wait, there's no people. So this makes no sense. Makes no sense. Makes no sense. This makes no sense. So this is undefined. So the key thing to realize, we say undefined in this situation, the key thing to realize is when does a fraction equal 0? That's when the numerator of the fraction is 0. So this is a key thing I want us to realize. Key thing I want us to realize. So if we have a rational function, which is p of x divided by q of x, what we should notice here is the x-intercepts. The x-intercepts, how do we solve for those? Well, that's when r of x is equal to 0. Well, if r of x is equal to 0, I'm solving this equation. But how am I going to know when this equation is 0? How am I going to know when this fraction is 0? Well, that's just when the numerator is 0. So when you're looking for x-intercepts, you only need to look where the numerator is 0. Again, if you don't like this quick argument I'm making here that a fraction is only a 0 when the numerator is 0, just use that great technique for solving equations to clear the fractions. Clear the fractions. These will cancel, and I'll just get right when p of x is equal to 0. So awesome. Okay, so starting off, so what have we learned here really quick? And we're going to do a couple examples, a couple more examples. One, how do I find how do I find y-intercepts? I'm going to plug in x equals 0, and I'm going to get our output. Okay, how am I going to figure out where the x-intercepts are? I'm going to figure out when the numerator is 0. Okay, y-intercepts, I'm going to evaluate the function at 0 and find the output. How am I going to figure out the x-intercepts? We're going to figure out when the numerator is 0. Okay, let's do some examples. Okay, I want to put a couple up on the board. I want you to pause the video and try all of these. Okay. Okay, first one. First one. Okay, try. Try. Okay. So, I want you to try it. Find x and y intercepts. Okay, I'm going to put 3 up on the board. Okay, so the first one, r of x being equal to, how about x squared plus 7x plus 12 all over 2x squared plus 4x plus 2. Go ahead and find the x and y intercepts. Okay. The second one I want you to try. R of x equal to 2 divided by x squared plus 3x minus 4. Okay, and the last one. How about r of x equaling x squared plus 4 all over, how about x squared plus 3x minus 3. Okay, go ahead, pause the video, and try to find the x and y intercepts for these 3 examples. Okay, let's go ahead and get started. For this first one right here, let's first find the y-intercept. The y-intercept is always the easiest to figure out. To find the y-intercept, I'm just going to evaluate this function at 0. Okay, notice that if I plug in 0, the x squared and the 7x term are going to get killed, and the 2x squared and the 4x term are going to get killed. I'm just going to be left with a 12 halves, or I'm just going to get out a 6. So our y-intercept is at the point 0, 6. This is our y-intercept. Let's go ahead and try to find our x-intercept. So our x-intercept is, we want to know when is r of x equals 0. We want to solve this equation. Okay. So recall, when I'm trying to figure out where the fraction is 0, where r of x is 0. Remember, a fraction is only 0 when the numerator is 0. So this just comes down to us having to solve x squared plus 7x plus 12 is equal to 0. Okay, you could use the quadratic equation here if you'd like. I'm always going to avoid the quadratic formula unless I really need to. I can hopefully see that this factors to, what is this going to factor to? I think x plus 3 and x plus 4. So we can see the solutions here must be x equals negative 3 and x equals negative 4. So we have our two x-intercepts, If I input -3, I'm going to get an output of 0. If I input -4, I'm also going to get an output of 0. So here we have our two x-intercepts. There's our first example. Okay, let's do this next one here. Okay, so let's first find the y-intercept. Okay, so the y-intercept happens when I plug in 0. So let's go r of 0. Okay, let's see what happens if I plug in 0. Okay, r of 0 here, I'm going to get a 2 all over. The x squared gets killed, the 3x gets killed. It's just going to be 2 over -4, so I'm going to get out a -1/2. So the y-intercept here, is going to be 0 and -1/2. There's our y-intercept. Okay, for our x-intercept, what do we want to do? We want to know when r of x is equal to 0. Well, notice here that if I'm trying to figure out where this fraction is 0, remember a fraction is only ever 0 when the numerator is 0. But the numerator here is 2. So what does this tell us? What this is telling us is that there's actually no x-intercepts for this graph. And let me show you. Like if you tried to solve this, 2 over x squared plus 3x minus 4. If you want to know when this is equal to 0, well, what would you do? You would clear the fractions. We would clear the fractions, so I'd multiply by x squared plus 3x minus 4 on both sides. X squared minus plus 3x minus 4 on both sides. Okay, these will cancel. And I'm just going to be left out with 2 equals 0. With 2 equals 0. Well, last time I checked, this is not true. This is what we call a contradiction. When you have a contradiction, a common math symbol is to have two arrows pointing towards one another. So what is this saying here? If I'm trying to figure out, well, when are the outputs of this function equal to 0? Well, the outputs of the function are equal to 0, provided that 2 is the same as 0, which is a false statement, which must mean that r of x is never 0. So what is this telling us? This is telling us that there are no x-intercepts. There are no x-intercepts for this example. This graph will never cross the x-axis. Okay. Let's do another one. Let's do this example over here. So let's clear up a little bit of room here. Okay. So recall that we're hunting for these features. It's not necessarily that a graph will always have a y-intercept or an x-intercept. We're just hunting for these things if they are there. Okay, this one here. Let's find the y-intercept. The y-intercept. The y-intercept happens when I plug in 0. Okay, well, what happens when I plug in 0? I think I'm just going to get 4 over -3, or how about just -4/3? So our y-intercept is at 0 and -4/3. Boom, 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 boom. Okay. Let's try to find our x-intercept. Our x-intercept happens. I want to know when the outputs of my function are equal to 0. Okay, so I want to know when this fraction is 0, but remember we discovered that we only need to look for when the numerator is 0. So here's x squared plus 4 is equal to 0. Okay, let's go ahead and try to solve this. We would have x squared would be equal to -4. If I square root both sides, x would be equal to the plus or minus square root of -4. So this is plus or minus 2i. So this graph has imaginary x-intercepts, but what does that mean in a sense for the real graph? When we're graphing something in the x and y grid, we're only graphing real numbers. So in this case here, when I get imaginary x-intercepts, what this tells us in this case is that there are no x-intercepts. So there, in this case, there are no x-intercepts. No x-intercepts. Okay. So those are the answer for these three. So like I said, there are situations where we won't have x-intercepts. we'll have y-intercepts. So in general, we're always hunting for x and y-intercepts, but they're not necessarily always going to exist. Okay, for this example, you might say, oh, well, you've given me 2 examples where x-intercepts don't exist. Are there situations where there'll be no y-intercept? Yes. Okay, let me give you an example of something like that. Okay. I'm trying to hit you with all different possible situations you could come across. Okay, one more. Okay, let's say that we have something like this. Okay, one more example. Let's say r of x is equal to, I don't know, how about x minus 1 all over x squared plus 4x, for example. Okay. So in this case, I guess if you want, pause the video and try to find the x and y intercepts. Let's first try to find the y-intercept. The y-intercept. Well, this is me, or us, going to be plugging in 0. Bless me. Okay. So if I plug in 0, notice what happens. I'm going to get a -1 all over 0. Uh-oh. Uh-oh, this is bad news. Can't divide by 0. Can't divide by 0. So what this is telling us in this example is there are no y-intercept. There is no y-intercept. Okay, what about the x-intercepts? The x-intercepts are going to happen when r of x is equal to 0. So I need to solve this equation when it's 0. But we learned that we just need to look for when the numerator is 0. So if I add 1 to both sides, I get x would be equal to 1. So here we would have no y-intercept. Here we would have no y-intercept. And we would also have an x-intercept at what? 1 and 0. Is there a situation where I'll have no x-intercepts and no y-intercepts? Yeah. I could tweak this problem. Let's tweak this problem. Let's just make the numerator. Let's make the numerator 2. Okay. Here's a good example. Let's make the numerator 2. Okay. So what is this going to change here? Well, for my y-intercepts, I'm now going to get a 2 over 0. I still can't divide by 0, so there's no y-intercept. Okay, x-intercepts, if I try to solve this, kind of similar to our last example, well, I would end up getting out, I would end up getting out, what, that's when 2 is equal to 0. We'd have a contradiction. So for this specific graph, this one actually has no x-intercepts and no y-intercepts and no x-intercepts. Okay, so we were hunting for these things to help us graph it, but for this specific example, we didn't find these. This graph doesn't have them. Okay, so I think I tried to hit you with every possible example I could give you. Okay, so this ends our video on trying to find x and y intercepts. In the next video, we'll try to figure out how do we find vertical asymptotes, and then how do we find horizontal asymptotes. We'll see you there. Take care.